Hello everyone, we are going to work on temperature XY and pressure XY diagrams in Aspen HYSYS. Last time I explained you how we draw XY diagram in Aspen HYSYS. Before I go into the details, I just want to explain you some points for better understanding of these diagrams. So our objective is we are looking to work on temperature XY diagram and pressure XY diagram. Now in these temperature XY diagram, our temperature is always on y-axis and x and y will come on the x-axis, which is usually x actually. I will explain you what are the x and y here. And similarly in the pressure XY diagram, the pressure come on y-axis and we have x here and x here. In x and y, this x is basically, this is the liquid mole fraction, and y basically indicates vapor mole fraction. Okay, the same thing applies here. In the pxy diagram, x is again the liquid mole fraction and y is again the vapor mole fraction. If you recall from our last lecture, we worked on ethanol and water system, and that's what we will be doing today. We are working on ethanol water system to develop Txy and Pxy diagram in Aspen HYSYS. In temperature, either temperature or the pressure, what is the x that we need to take of the either of ethanol or the water? Now keep in mind, ethanol, let's write it here. Ethanol has a saturation temperature or boiling point of around 78 degrees Celsius. More precisely, it is 78.37. And for water, we know that this is 100 degrees Celsius, the saturation temperature of water. Because this boiling point or the saturation temperature of ethanol is less than the water, so this is called as the more volatile. This is called as the more volatile component. And of course, because if there are two components, and ethanol is more volatile, then the water will be a less volatile component. So on x-axis, we take the x of more volatile component. So I can say that my x will be of ethanol here. And the same is true for pressure diagram, where the x is taken as the ethanol. So always remember that more volatile component will come, the x of mole or I must say the liquid mole fraction of more volatile component comes on x-axis. So that is why I'm taking here x of ethanol, not for water, because ethanol is a more volatile component. Now this diagram basically comes something like this. We will draw it in HYSYS and see how it looks like. Now over here, now let's choose a different color here. Let's take the light blue. This line is what we call as a dew point line. Dew point. And this line is what we called as a bubble point. Now anything which is above the dew point line, this is your dew point line, anything which is above the dew point line, that is what is in the vapor form. These are anything above this line is the vapor form. Anything below bubble point, that is in terms of the liquid form. So this region basically I would say that this is a liquid region. Okay, now you can ask me where is the two phase region lies. So anything which is in between my bubble point line and the dew point line, that is what is the two-phase region. It has the liquid as well, and it has a vapor as well. So that region is what we called as a two-phase region. It contains liquid and the water both. Now how we do analysis on these diagrams? So let me erase this, and I will make it as a temperature diagram and explain you over there. So let's say this is my temperature and x and y diagram. Again, the same shape will come here. I know my drawing is not that good, so just bear with me. So this is my diagram for a temperature xy. Now for example, we take a point, for example, we take a 0.11 ratio over here, let's say. Now on this point we can see that there will be some temperature. So let's suppose that this temperature is 80 degrees Celsius. And what we are doing, we are increasing the temperature of the system which contains ethanol and the water. This is my dew point line, and this is my bubble point, as I explained you before. Okay, so I'm increasing the temperature, and the temperature will go slightly above here. So what will happen now? We are in the two phase, and how do we find our compositions? So in order to find the composition of the vapor form, you go on the right hand side, you touch this dew point line, and then you go down straight to the bottom and see what is your composition here. So let's say we start from 0.5 here for this one, and this one is coming as a 0.6. So I can say that my vapor mole fraction, this is the vapor mole fraction of ethanol, which is equals to 0.6. That is what we have here. If I have the vapor mole fraction of the ethanol, and what will be the vapor mole fraction of water? Of course, there are two components, so we will have for the water it will be 1 minus 0.6, so this is equal to 0.4. So you can say that on this point the vapor mole fraction of the ethanol is 0.6, which is coming directly here, and 1 minus 0.6 is 0.4, that is the vapor mole fraction of water. Okay, now if you are looking to find out for the liquid, let's use black color. So on the same temperature line, instead of going towards the dew point, you come on the left hand side, which is your bubble point, and we go back down here, and I can see that, let's say this is 0.3. so let me do it here. So I can say that my mole fraction, the liquid mole fraction of liquid, again this scale was for ethanol, liquid ethanol will be equals to 0.3. and if I want to find out the mole fraction of water here, liquid water, that will be equals to 1 minus 0.3, which is equal to 0.7. So that is how you analyze your temperature XY diagram. Same analysis is performed if you have the pressure here instead of the temperature. So I hope this clarifies. The main point are that if this is my dew point, anything above the dew point is the vapor form. This is my bubble point. Anything below the bubble point is my liquid form. Anything in between bubble point and the dew point is my two-phase diagram. You can choose one point on the two-phase, go on the right hand side and go down if you want to find out the vapor mole fraction of both components, and if you want to find out the liquid mole fraction of both components, just go towards the bubble point. Now let's go in Aspen HYSYS and do it there. So as I mentioned, I'm doing the same XY properties as we did last time in the video lecture. I will leave its link in the description, and you can have it and understand how I developed that diagram. So I'm starting from the scratch. I add the components. We know that this is my ethanol and this is my water system. And then we go to our fluid package. The fluid package in this case, as I showed you last time, it is very critical to choose the fluid package for XY diagram, TXY diagram and PXY diagram. I'm going to choose the Wilson, and then we go to our simulation environment. In the simulation environment, go to the external model, and this is the equilibrium unit that you need to choose and bring that into your solver. Here, double click on this and now over this point we are doing the binary. We are not doing ternary. I will do some other time ternary. In the ternary we need to have the three components, and we explain the liquid extraction and the vapor liquid extraction. We are not doing this one. We are doing on the binary. We have done XY plot last time, and today we are going to do the temperature XY plot and pressure XY plot. Select a temperature XY plot, and it is important that you add the component. Click on the component and click on add component, and then add water as well. If you are drawing your TXY diagram, you must provide one pressure, and as you can see that it is not allowing me to enter the temperature because I am dealing with the temperature XY diagram. If it is a reverse case, let's say we are looking to draw pressure XY diagram, it will not allow you to enter your pressure, and it will ask you at what temperature you want to draw your PXY diagram. And it does make sense, because in the PXY diagram pressure will vary as I show you on the diagram, and it will come only on one temperature. So let's do TXY diagram, and this temperature XY plot will be on one pressure. So let's say I use 1 atmospheric pressure, and once you have selected your pressure, just click on the plot here. So that is your outcome here. This is your TXY diagram. As you can see that this is your bubble curve here. Anything below this is the liquid form. For example, if you are at this point and you have this 80 degrees Celsius, so you can easily find out what is the liquid mole fraction over this, because everything will be the liquid here. Now this is my dew curve, as explained you. Above the dew curve is the vapor form here, and inside this is your binary system. It has two phases, liquid and the vapor here. Now there are a couple of things that you can do. You can click on the view table, and this will generate a table. You can either export it, or you can just select it. You can just select this table and copy paste it. Just right click on this. You can copy it and paste your data in Microsoft Excel or any tool that you would like to draw the graphs in, and or you can just right click on this and go to the copy and go to the scale by 100. It will automatically copy your this diagram, and you can paste it into your Microsoft Word directly. Now second thing is let's do it on the pressure. Similarly, this is my PXY. Let's say I draw it on a temperature of 100 degrees Celsius, and just click on plot again. It will give you the PXY diagram at 100 degrees Celsius. Now just keep in mind again, this is my pressure here, and on the x-axis I have x of the ethanol, which means it's a liquid of the ethanol. Why it is ethanol? Because I show you that ethanol has a lower boiling point than water. Because it has a lower boiling point than water, therefore it is more volatile. So that's what it will select on your x-axis. And the same thing you can work on. You can click on the view table, copy this this data from here, or you can just export to the file and you can do your analysis on this. One thing I want to explain you, if by chance you have removed one of your component and you try to plot it, it will never plot it, because as you can see that on my error here, it is giving the message it is not solved, because XY diagrams and PXY diagram, TXY diagram, they are plotted for the binary system. So according to this situation, the system only has your ethanol in it. So make sure you add the second component, and then you must plot this and work on it. At some point I will try to make a video on how we work on and develop liquid equilibrium diagram and vapor liquid equilibrium diagram. Okay, and I hope this helps, and if you have any questions you can email me. Thank you.